In this video, we're going to do a real quick overview of the features and some of the syntax of the C language. The intention of this video is you're coming from a language, say Java, and you want to get into C programming. This will sort of introduce you to some of the concepts that you know from your previous language, and now you can see how those same concepts are applied in C. So let's take a look at what this program looks like. Specifically, we'll talk about some of the data types and how to create variables, how arrays work. We'll talk about the user-defined types in C. Specifically, we'll talk about structs, and we'll also talk very briefly about how to write functions. And then we'll also talk about some of the things you have to be aware of when you're writing C code, especially if you're coming from a background in a language like Java. There's definitely some major differences. So right here, we have a pretty basic program. We have these two includes, and those are telling the compiler what functions we're pulling in from the language. So standard IO, that's where printf is and some other functions. And we'll do some work with strings as well. And so we're including that. Now, we don't need it yet, of course, but eventually we will. So here's a comment that talks about what we'll eventually fill out this program with. And at this point, we just have a simple hello world. That's all this program does. So the printf is the output statement, and we print a string. Printf doesn't generate a new line, so we hard code a new line \n at the end of our string to indicate that we want a new line in the output, and then we return 0 to indicate that the program completed successfully. So GCC standard C11, turn on all the warnings, pedantic, and it compiled. Since I didn't tell it what the name of the executable should be, it by default goes into a.out. If you're using Cygwin, it'll be a.exe. And when I type /a.out, I see the output of my code. So the first thing we want to talk about is some of the data types. So we can have integers, and we'll go ahead and initialize that to 10, although C doesn't force you to initialize your variables. We have a character type, and the character literal is a single character in single quotes. There are some escape characters like the new line, and so we could do slash and then one of those. So there may be two characters sometimes in single quotes, but it represents a single character in that case. An array, and this will be an array of 5 integers, which we're not initializing. Here's another array that we're not going to give a size to, but we will initialize it. And so it'll be an array of size 4, since we're initializing it with 4 values. And it looks like I didn't give my character a name. Now we can also have character arrays. So I'll create one called hello, which will have the characters H, E, L, L, and O. I'm also going to add a null character to the end of this, and that actually will make this a string. And I can also create a character array that's initialized with a string literal. Okay, so let's print some of these values out. To print a value in my string, I have a control sequence that represents the type of what it is I'm printing. And then once the string is over, I give it the values I want in that sequence. So we've saved this. Let's compile it and run it just to make sure we don't have any typos. And there's some warnings of unused variables. And again, normally you want to take care of warnings. I know I haven't used those yet, so I'm going to ignore those. And then you can see it prints 10 and K for X and C. And I'm missing a new line here. Now these control sequences are important. If I print X using the control sequence X, which stands for hexadecimal, and the character with D, which is the one for an integer, now notice on the second line, instead of 10, it prints A because A is 10 hex, and 75 is the ASCII value of capital K, and so that's why that gets printed out. I didn't change the value of the variables, but I did change how I was printing them out. And so that's something you want to be aware of. It's really easy to think you have a bug, oh, I'm getting the wrong value, but sometimes it's because you're printing them in the wrong format. And I hate lowercase hexadecimal values, so I'm going to use a capital X as the control sequence here, and that'll print that in uppercase. And so there you can see we have an uppercase A. If I say hello equals, for a string, it's a %s, and then the size of hello is going to be a long unsigned integer, so that's LU. And I'm going to do the same thing for world. So hello has 1, 2, 3, 4, 5, 6 characters in it. World has 1, 2, 3, 4, 5 characters in it. So let's see our result. And you'll notice it prints both of those out, but notice how size of, they're both 6. And the reason is in C, strings are null terminated character arrays. So by putting a null here, this becomes a string. This is a string literal, so there's a null terminator at the end. So we have the 5 characters of world plus 1 null terminator, giving us 6 total characters. And you'll notice if I hover over in Visual Studio Code, it actually will tell me that that's a character of size 6, even though I didn't initialize it. So that's our data types and our arrays. And of course, there's more that we could have talked about, but these are some of the ones that are most common, and we'll have other videos going over more of those later. So for a user-defined type, it's a struct, and we'll just do a real simple struct that'll have an integer, and it'll have a char array of size 10. And so now I can create a simple struct variable, and I'll call it thing. So it's a struct, simple struct variable named thing, and I'll initialize it with 25 in Arizona. So how do I print this? So we'll come down here, we'll print thing, num is equal to an integer, and name is equal to a string. And to get the fields out of the structure, we use dot notation. So thing.num, thing.name. Now if I want to change what's in the structure, I can do that. Let's say I want to add 10 to it. And then if I say thing.name is equal to, and we'll think of a different name, we'll just say, actually, before we change that, let's do this. Let's say thing.num4 is equal to x. And then we'll print that out again. So notice we didn't change the string, we just changed one element. And why is that giving me an error? Because that should be thing name. Okay, so let's print this out, or let's execute this, and you'll notice index 4 of the name got changed to the capital X, and we multiplied num by 250 that second time we printed it out. Okay, so now let's say thing.num is equal to 2021, and thing.name is equal to Texas, and let's print that out. And you'll notice we get an error, assignment to expression with an array type. I can't use assignment with an array. So what I have to do, if I want to copy a string, I've got to use string copy. Thing.name is the destination. I want to copy the string Texas, and there's 6 characters I want to copy. 5 characters of Texas plus the null terminator. Now, this will do what you expect. And so you can see it's updated num, and name is now equal to Texas. So that's a tricky thing to keep in mind when you're working with strings. And you'll notice later on there's going to be a lot of examples with strings because there's a lot of places where you can go wrong. Okay, so let's do something with nums. So let's create a for loop. And I always use double letters for my indices just because it makes it easier to search for. Modern IEs mostly render that pointless, but it's still a habit that I'm in. And I also have gotten to the point where I like how it looks having a non-single character loop. So that's why I do that. There's nothing magical about II as a name. So what do we call our array? We called it nums, and we also have vowels. And let's make both of these the same size, just so that we can print them both in columns if we want to. So nums II is going to be equal to, and let's say vowels II times II. Actually, to make this interesting, since we already initialized those to 1 through 5, let's change these numbers. So we'll say 3, 7, 5, 1, 10. I don't think that'll mess anything up that we have. And so in this loop now, we're changing what those things are. So let's print the values out. We'll do a while loop this time. While JJ is less than 5, printf val %d equals some number, and nums %d equals some other number. So val jj, and nums jj. And then we need to increment jj. So there's an example of a while loop. So val is undeclared because it's vals. That takes care of that. We're also missing jj and jj because notice we have 4 control sequences here, so we need 4 values after the string. And now notice we got rid of all our warnings, so that's always good. And you can see there are the results of whatever we initialize those things to be. So I think essentially num should be the index times whatever this value is. And so if you look down, you can kind of see that that's what happens. So the last thing we want to see here is how we create functions. So let's write 2 functions. One will be a procedure that doesn't return any value. It'll just be print num, and it'll take an integer. And it will say the number is %d. Pretty boring function, really. And let's write another one that returns a value. So it takes 2 integer parameters, and it returns their sum. So pretty straightforward. Now, in our code, let's call these. So we're going to print, let's start off with, we'll just print a number, 6. And then let's print our variable. Remember, we have that integer variable, so let's print that. And we can also print a single index in an array, so let's do nums 3. And then we can also remember that add numbers returns a value, so I can add numbers, and we'll add vals 2 and 10. And then we could also say nums 0 is add numbers, and let's say we'll add vals 2 and x plus 4. Right? So again, this gets evaluated to some expression that has the value of whatever x plus 4 is, and then that will be what gets passed to the function. So you can do things like this to, a lot of times actually can clean up your code. You don't have to have extra variables and so forth. And let's now print num 0. And that looks good. So let's run this. And you'll notice I'm getting some warnings. Implicit declaration, conflicting types, which seems weird. But the reason you get this is that when it sees a function that it doesn't know what the parameters and return type are, it just makes assumptions. And of course, that assumption sometimes is right, which sometimes lulls you into a false sense of security that you're doing things okay, but most of the time it's bad. So actually what we need to do is create what's called a forward declaration. The forward declaration will go at the top of our file, and it's just going to be the signature of the function. So then the return, the name of the function, and the type it's going to return. And you can put the variable names in there or not, it doesn't really care. So I'll do it one way with the names, one without. It doesn't matter either way. So now if I run and compile this program, you can see that those numbers get printed out, and some of those get adjusted based on the result of that add numbers function. So I'm going to go through and add a couple comments here. And the strings are also arrays. And the struct type is actually a variable. So here we're printing the values of the array. And let's also print some new lines here. And I'll indent this so that looks a little nicer. And then finally, I think it'll make sense to do something here. In fact, we could even say that we're printing the num, just so that we know what's going on in the output. And we'll call this loops. And then finally, we have function definitions. So let's compile this and just make sure that it works. And everything looks pretty good. And so that's a quick overview of C. There are several topics we haven't talked about. We haven't talked about the preprocessor really. We haven't talked about pointers and so forth, but we'll get to those in later videos. But this is a really good, just sort of really quick, drop you in introduction just based on what we've covered here, if you've seen a language in the past like Java or something, this is probably going to give you enough where you could actually start writing some C programs just based off of what you already know plus this quick introduction.